An amusement park ride rotates around a fixed axis such that the angular position of a point on the ride follows the equation theta of t equals a plus bt squared minus ct cubed, where a equals 1.1 radian, b equals 0.4 radians per second squared, and c equals 0.03 radians per second cubed. Part A, determine an equation for the angular speed of the ride as a function of time, omega t. This is just d theta dt. We get 2bt minus 3ct squared. Part B, besides at t equals 0, at what time t1 is the ride stopped, we can divide out by the t for the t equals 0 root. We get 2b minus 3c t1 equals 0, so t1 is 2b over 3c, or 8.889 seconds. Part C, what is the magnitude of the angular displacement of the ride in radians between times t equals 0 and t equals t1? We plug in those two times to our expression for theta and take the difference, and we get 10.535 radians. Part D, determine an equation for the angular acceleration of the ride as a function of time, alpha t. This is just the time derivative of the angular velocity. We get 2b minus 6ct. Part E, what is the angular acceleration when the ride is at rest at t equals t1? We just plug in the t1 we found earlier, and we get negative 0.8 radians per second squared.